And now our question is figure 2 is a casted block drawn in isometric projection, and this is the figure. Now we are going to I'm going to draw the number, and you are asked to draw for size the following views in first angle orthographic projection. And I'm going to start with the front, a section of front elevation on the cutting plane PP. Now P, from our question, it is here. It comes like this up to here, and I'm going to start off. Okay. Now, when you look from here to here, that is 120. So I'm going to measure 120. That is 120. Then I'm going to draw my parallel line. Just to be faint. Yeah. And then they say from this point to this point, which is 20. So I measure 20. Can look at it. 20. And as well from this point to this point, 20. Can broaden it because it is seen in the front view. Now we are drawing a sectional front elevation from the cutting on the cutting plane PP. Yeah. So now from this point to this point, it is 40, 44. Now we are going to first join these two points together, because we will need them later on to project our end view under the plan. Just be faint line. There it is. On this, we measure 44. That is 4.4. 4.4 is there. And then from this point, this is the point, up, it is 36. Can you look at it? 36 up. So we draw a perpendicular at 44. There we are. Remember, we have our middle line vertically, horizontally and vertically, 1 centimeter away, 1 centimeter away, 1 centimeter away, 1 centimeter away, and these are our 4 quadrants. This is my title block. I'll leave it at the end. Now, on this point, 44, it is 36. So I measure, that is 3.6 up. There we are. Can broaden. That is it. Now, and there's a line joining. There's a line joining. So you can join it. Yeah. Then from this point, to a certain point here, it is 72. It is 72. But we know from here to here is 120. From here to here is 44. From here to here is 72. But when you get 120 minus, that is, you can put into brackets, 44 plus 72, we get 116. That means there's a distance of 4, which is not catered for. So that means that by drawing, if I want to know where this point is, 72, I've got to take the 4, that is 4 millimeters. And what is that? If this is 120 and this is 4.4, then we measure, that is 72 on this line. It is somewhere around there. So we draw perpendicular. This is our 72. So we have to draw perpendicular here. We join the points. Is our perpendicular. And then on this point, we can measure our 36 so that we can draw and join the points. And there we are. And we can join it, bring it down. Yes. So now we have an inner, remember we are sectioning it. It is being sectioned, but still, as it's being sectioned, there's something like a rectangle. Now, if you can look from this point to this point is shown as 6, and from this point to this point it is 14 millimeters. That is 1.4. From this point that is our 1.4. Now we draw a perpendicular using your set square. There we are. Now on this line you measure your 6. It's around there, and then from this point up to another corner of that inner rectangle, it is said to be 36. That is 3.6. So 3.6 somewhere here. So we draw perpendicular. And as well, we do the same thing. Now, this is our two corners, 2 points for the inner rectangle. So we draw a line joining those 2 points because we need these lines in projecting. So we extend it. It has to be a faint line. And then we can join these 2 points. Remember, when you draw accurately one, that is the front view or plan, if you're in the first angle of projection, you start with the front. When we're in the third angle, the front is ever down, the plan is up. So it matters which angle you start with. The first drawing you draw, it helps to draw the rest because these lines, they help in projection. Now, moving up, from here on this line is said to be 2.4. So you measure 2.4. 2.4 is somewhere, if you have a T-square, it is very good. That is our 2.4 is somewhere there. And as well, we measure 2.4 is somewhere there. Then you join the 2 points.